Welcome to Summarize Science, where we break down the latest research. Stitching up a wound is one of the most common and critical tasks in surgery, but it requires incredible precision and a steady hand, and quality can vary. Researchers are developing robotic systems to assist surgeons, and their latest version, called Stitch 2.0, is a huge leap forward. As you can see in this comparison, the previous system, Stitch 1.0, struggled to make tight, clean sutures, but Stitch 2.0 creates sutures that are uniform and fully close the wound. To understand why this is such a big deal, we need to look at the challenges the old system faced. It often had trouble tracking the needle's exact position, leading to errors, and it had a major problem with managing the surgical thread, which would frequently get tangled. Stitch 2.0 tackles these problems with several key upgrades, which can be grouped into three main categories: seeing the needle better, planning the suture better, and handling the thread better. First, to see better, the system uses a sophisticated AI to identify the needle in the camera feed. It then applies clever image processing tricks to reduce visual noise and create a clean, skeletonized outline of the needle. This clean data is fed into a smart prediction filter, an extended Kalman filter, which creates a highly stable and accurate 3D model of the needle's position and orientation. This allows the robot to know exactly where the needle tip is, down to the millimeter. Next, instead of needing a human to tell it where to stitch, Stitch 2.0 uses 3D suture alignment. It scans the wound, creates a 3D point cloud, and automatically calculates the optimal, evenly spaced locations for each stitch. This autonomous planning is designed to promote better healing and reduce scarring. Finally, to solve the tangled thread problem, the researchers programmed a new set of coordinated movements. As you can see here, after the needle passes through the tissue, one robot arm performs a sweeping motion to move the thread forward and out of the way. This ensures the thread stays in front of the needle during the extraction phase, which prevents tangles and improper stitches that plagued the previous system. So, how much better is it? The results are dramatic. Across 15 trials, Stitch 2.0 successfully completed 66% more sutures than Stitch 1.0, and it did so in 38% less time per suture. Most importantly, it achieved a 74% wound closure rate, a massive improvement over the 22% from the old system. This highlights the core idea of augmented dexterity, where the robot isn't replacing the surgeon, but acting as a tireless, precise assistant. In experiments where a human was allowed to intervene just once or twice to fix a rare error, the system achieved a perfect 100% wound closure rate across all trials. This human-robot team approach combines the consistency of automation with the adaptability of a human expert. To recap, Stitch 2.0 represents a major advance in robotic surgery because of its superior needle tracking, autonomous suture planning, and intelligent thread management. This means the robot can perform the repetitive task of suturing with high consistency and quality. While it's still slower than a human surgeon and was tested in a lab setting, this work paves the way for a future where robots handle tedious surgical subtasks. This could reduce surgeon fatigue, increase the consistency of surgical outcomes, and ultimately improve patient care.